Hello everybody, thank you for joining me today. My name is Willem and today we're going to be looking at radioactive decay. So some of our learning objectives are to understand the process of radiation and radioactive decay and to recall the features of the three main forms of radioactive decay, so alpha, beta and gamma. Now this is quite a big and important topic, so I hope you're ready for this. Let's get right into it. Okay, to understand radiation, there are two main concepts that you really need to understand, right? And those two are stability and decay. So stability and decay are linked very, very closely because for something to be more stable, it can it can decay. Okay, so let's talk a bit about stability. So stability really talks about how happy an atom is in its normal state. Okay, so an atom contains, as you know, a number of protons and number of neutrons. Okay, so neutrons really exist to spread out charge. Okay, spread out charge in an atom. So if the number of protons is roughly equal to, so this curly line here represents approximately, so if the number of protons is approximately equal to the number of neutrons, the atom is fairly stable. Okay, atom is fairly stable. This is because the neutrons really push about the positive charge, spreading it out thinly and evenly, so there's not too much in one little place and not too little in another. So the atom is happy where it is. It's stable. Okay, but when you start getting more protons than there are neutrons, you start to get pockets of extra charge. Okay, so you can think of this a bit like a tower, right? So let's say when the number of protons is equal to the number of electrons, right? Our tower is stable on equal numbers of protons and neutrons, right? I'm just going to do a few just to illustrate the idea, okay? But now, say in my tower, right, I had more protons than I had neutrons, okay? 4, 5, right. Now, if I was to rest my tower on here, it would be unstable. Okay, can you see that, right? So this is why number of protons and number of neutrons is very important to stability, how happy the atom is in its current state. This is not something that you need to know a lot about at GCSE level, but when you get to A level, you do need to understand it. Now, when an atom is unstable, it can undergo decay. So decay is the process of emitting particles to achieve stability. That's what an atom all wants. Kind of like humans, really. All we want is stability. Okay, so decay is the process of emitting particles to achieve stability. Now let's understand what kind of particles we can emit. Okay, so here I have my nucleus, right? And my nucleus is unhappy right now, okay? That's because it's got too many protons, okay? So now my nucleus has three main options for becoming more stable, okay? It has the alpha emission route, it has the beta emission route, and it has the gamma emission route, okay? So these three types of radioactive decay, that's what they are: alpha decay, beta decay, and gamma decay, help atoms become more stable, okay? So let's have a look at alpha decay. An alpha particle is merely just alpha particle is just a helium nucleus ejected, right, or rather radiated, right? That's where we sort of get this idea of radiation, because it's being radiated out of the nucleus. That's a very key point. It's being radiated out of the nucleus. You have to remember, alpha particle is just a helium nucleus ejected out of the element's nucleus. Okay, let's highlight the words nucleus there, because these are very important words, right? A lot of people think that the radioactive particles are just given out of like shells. No, they're not. You have to say that they're given out of the nucleus. Okay, so an alpha particle is just a helium nucleus, so that means 2 protons, 2 neutrons. So let's draw those in: 2 protons, 2 neutrons, and this is given the symbol He, or which is 4, mass number 4, and proton number 2. Or we can look at it like this. So it's sort of like the Greek letter alpha, which kind of looks like an A, like that, and that is also 4 and 2. Okay, so 4 mass numbers because it has 4 particles. and 2 proton numbers because it has 2 protons. Okay, so that's our first route to becoming more stable. Okay, ejecting an alpha particle out of the nucleus. Then we also have beta particles. Now beta particles are high speed electrons ejected from, again, the nucleus of decaying elements. Okay, so if here we have our nucleus, right? Our nucleus can eject out of it a high-speed electron, E minus, and that one we call a beta particle. Okay, so as a result of beta decay, remember the element wants to become more stable. So as a result of beta decay, a proton turns into a neutron. And there you go. By that way, we reduce the proton number, we make our element more stable, and so it doesn't need to decay any further. Okay, so let's highlight all of these words. So as a result of beta decay, a proton turns into a neutron. Okay, now you have to remember that. Now, again, the symbol for beta decay, we can use a B like this, and it has a massive 0 minus 1, or rather at GCSE we technically use just E minus, right? That works as well. Then we have gamma rays. Now gamma rays actually have no mass, and they are just a bundle of energy given off as gamma, right? So it has this symbol here, gamma, rays. Now if we remember our electromagnetic spectrum, gamma rays are way at the edge of it, which means that they have an extremely short wavelength but also very, very high energies, right? So gamma decays are just electromagnetic rays emitted from the nucleus to give off some excess energy. But now a point about gamma rays is that gamma rays themselves can't really make a nucleus more stable, simply because they just can't carry away enough energy. Like the nucleus of a decaying atom has so much energy. In fact, that's how nuclear reactors work, which is something that we're going to look at later on. And gamma rays itself cannot get rid of enough energy, so this is usually just a part of decay rather than all decay. Okay, so often we see an element that's decaying, it gives off alpha plus gamma, or rather it gives off beta plus gamma rather than only gamma itself. Okay, so now these are the 3 routes that a nucleus of an atom can take during radioactive decay. I know it's a lot of new terminology, but if you go through this very slowly, working your way through the logic as always, as we do in all of physics, I'm sure you'll understand this very thoroughly. Okay, now you also have to understand some features of all of these different types of radioactive decay. But first of all, the biggest thing that you need to understand about radioactive decay in general is that it has 2 main features. One, it's spontaneous. So this means that it can happen at any moment. There's no way to predict the exact time a nucleus will decay. Okay, so that's the first overall theme that you need to understand. And the second theme that you need to understand is that it's random. So you cannot predict exactly which nucleus will decay. Okay, so now let's have a look at a closer look at the different types of radioactive decay and what they're stopped by and their strength. These are things you have to remember. Okay, so let's have a look at alpha particles like this. So an alpha particle is a big helium nucleus. Okay, because it's such a big particle, it can actually be stopped very easily. So it can be stopped by a A4 sheet paper, as in the thickness of an A4 sheet of paper, not the surface area, the thickness, or 5 centimeters in air, or a layer of skin. Well, I should really say top layer. Okay, but because it's also such a big particle, it's very ionizing. So actually, let's just keep it in a common color. Very, or rather strongly ionizing. Okay, so those are the two features of alpha that you need to remember. Now let's have a look at beta. Now remember, beta are high-speed electrons, or rather E minus. Okay, because they're moving so fast, they can travel a bit farther, so they have a range of 3 meters in air. Now these values like 3 meters, 5 centimeters, these can vary a bit, but if you say a meter in air, that should also be fine. But something that is very commonly quoted also is 3 millimeters of aluminium. So a 3 millimeter aluminium sheet will also stop beta radiation. Now, because their electrons are so much smaller than alpha particles, they're not as much ionizing, so they're moderately ionizing. Now, if you've forgotten what ionizing means, to ionize means to knock electrons off. That's really that's really problematic for like organic beings like us, because if you knock electrons off, say DNA, that can mutate it can cause cancers, right? So that's what ionization is, removing electrons. Now let's have a look at gamma. So remember, gammas are electromagnetic waves that carry a bundle of energy. Because they're waves, they can travel through, they can only be stopped by meters of concrete or thick lead sheets. Okay, so gamma radiations are very, very penetrating, right? They can go very far before they're stopped. But because they're only electromagnetic waves, they're not very ionizing, right? Because they penetrate so far, rather than doing damage, they just go straight through things.